Hi, welcome to the November 15th meeting of the CNCF IoT Edge Working Group. Um, we've got a fairly light agenda today after coming back from KubeCon North America last week. So anybody here is free to add items to the agenda, or we'll go into free form birds of a feather discussion if we have leftover time. One item I did put on the agenda was a recap of KubeCon. So they just published the videos yesterday, I believe, and I listed all the sessions on the Kubernetes on the Edge Day. There are links there from the speakers who did upload their decks, but that's probably slightly less than half of them. And I started posting the links to the videos on YouTube, but I only got about a third of the way done. I'll finish that later today so that if you go back to that agenda notes document later in the day, they should all be there. I'll probably also go into the main KubeCon event. So what I started doing was just the sessions from Kubernetes on the Edge Day. However, there is a lot of overlap. So as Liam's away, there was a WebAssembly day that had a lot of overlap with Edge. There was also a telco day. And the Made KubeCon event actually rated some of the submits to the Kubernetes on the Edge day. So we aspired to have a big, just because of the excitement over AI and ML at the Edge, we wanted to put sessions there, but they decided that they were of such interest that they've moved them into the main KubeCon event. So I think there were 7 Edge-related sessions in the main KubeCon event the rest of the week. And I'll try to gather links and decks for those and put them in the agenda notes document as well. For the Kubernetes on the Edge Day event, I particularly like the sessions on automating an oil field, and there was one on using the Istio ambient to join things into a service mesh. There are facilities there to, normally an Istio service mesh includes Kubernetes hosted workloads on a Kubernetes cluster, but there are ways to bring in things that are not part of that cluster. And they had a live demo using Raspberry Pis of doing exactly that. And I thought that was a pretty good session. I won't tout my own opening or Tina's closing, but those had a lot of material on this group. In terms of what I saw at the conference that was interesting, I had an interesting discussion with Sony about their Wedge project. That's the WebAssembly adapter for machine learning at Edge, but it still has not been open source. They still are saying it will be soon. I think that was the more interesting thing. If I have to pick one thing, that was it. Liam, you were there, so anything you want to add on your observations, comments, or suggestions for interesting sessions or talks you had on the conference floor?
I really also appreciated the Sony Midakura Intel AI ML on Edge piece. We know that team from the WebAssembly community, and they build on top of Whammer. It's actually not a Linux-based device, so it's really micro when you look at the specs and what they're doing on the device. It's really neat. They've got a workflow for training and adding new ML models to the ecosystem, which is cool. At Cloud Native WebAssembly Day, I was chair, so we're quite busy with sessions and doing our own moderation. I apologize I wasn't able to come over and attend this working group sessions. I think the most important talk was the keynote by Bailey Hayes and Kate Goldenring, where they took a WebAssembly component, which is a standard for a portable unit of compute, and they ran it across different runtimes. That was the big story. The second biggest story for WebAssembly was that there's a huge number of people that are coming out and supporting the WebAssembly component. So CNCF WASM Cloud has support. CNCF WASM Edge announced that they are working on support. WASM Time in the Bytecode Alliance is there, and a number of runtimes as well. So it seems to have picked up some mind share and is, I think, one of the more exciting pieces. There were a ton of great talks at Cloud Native WebAssembly Day. There were talks about everything from how do you orchestrate across the edge, reconciliation controllers for the for WebAssembly workloads, and the Istio ambient mesh was over in Cloud Native WebAssembly Day as well, which was super interesting. It of course has WebAssembly baked in.
Yeah, speaking of talks, just a reminder for KubeCon Europe, which will be in Paris. I can't remember the dates, but next year, the CFPs are open for about 2 weeks more. I did the Kubernetes. There will be a Kubernetes on the Edge Day event there, but that is not open yet. They're still kind of assembling a program committee for that. I did also hear of something new and I thought it was a great idea. It was kind of fascinating that they're going to do for Europe. They're planning trains to go from major cities in Europe that have direct service to Paris. And they have arranged the first one already going from Zurich, but they aspire to getting them from other major cities in Europe. The idea is that you'd be able to buy a train ticket. They'll have reserved train cars, and they'll be doing tech presentations on the train as you would ride to Paris. So Zurich is kind of a short ride, so they'll have 5 hours of presentations, but from some other locations, I suspect it might be longer than that. So anybody who aspires to talk or to listen to talks might want to keep an eye out for that. I'm not in Europe, but if I was, that sounds like a far more entertaining way to get there than riding on an airplane. Just throwing that out there. Was anybody else on the call at KubeCon and have any remarks? Sounds like not. Okay, I think we're out of agenda items unless somebody added one while I wasn't looking. Let me take a quick look.
Sorry, yes, I was at KubeCon also. I did not get to go to Edge Day. However, I was running another event on that same day.
Okay, and I see you're from SUSE, so I know that you had some demos in your on the exhibit floor related to Edge. So you're free to talk about anything open source that you want to related to IoT and Edge.
Yeah, I mean, I think so. I did run into Kate Goldenring there and commented to her that I'd like to see this group move more towards some work in sort of implementation. Like I'd love to do some development with the people here and try new things and sort of push the envelope on what we can do at the edge in general. As sort of outside what SUSE is doing, outside of what Red Hat and other companies are doing. Just I have some ideas. Love to throw them around at some point and see what people think.
Okay, we're pretty open on this, so you're welcome to go pick a future date and go edit the agenda notes document. Just go put whatever you'd like on the agenda notes, whether you just want to discuss your idea or open this up for a workshop or some plan to actually do some kind of exercise. Just go for it.
Great. Okay. Yeah, that's what I'll do. Maybe in the new year, though, I know everybody's going to start to get distracted in the next couple of months, but
okay.
I will definitely look towards the new year for doing that.
Yeah. And maybe if you want to, you could put just an item to discuss it, where maybe we could aspire to actually doing something. I don't know where you're going with this, but I sort of got the impression as I was trying to figure out what this might be is if you were proposing we do some group effort on some kind of lab or workshop, that sounds great.
Yeah, I mean, I think there's workshop possibilities, but I'd love to just have the discussion and get people's thoughts. And I think we've talked quite a bit about some of the limitations of Kubernetes and cloud native at the edge, and I'd love to kind of explore that some more in conversation and maybe in workshopping as well. So I'll definitely, maybe if people want, I guess in 2 weeks we could just have a discussion, and then if not enough people show up, we could resume the discussion at a later date or something like that.
Yeah. Yeah. Limitations on Kubernetes sounds like a great topic. I mean, there's everybody here is seeing countless presentations by some vendor trying to sell you Kubernetes that tends to dwell just on the good side, and yet to be of use to users, the coverage of downsides, and there are some, are much lighter because, it's not generally in the interest of some vendor. And let's face it, that they're the ones who compose a lot of these talks to be pointing out impediments that would slow down or prevent a sale. So yeah, that sounds like a fascinating topic. It does come up from time to time here. I think Frederick of the Eclipse Foundation has a full presentation on kind of limits to Kubernetes and alternatives. So that does sound like a topic that we've covered before, but it's of interest.
Okay, great. Thank you.
Anybody else got anything? We're now going into the birds of a feather mode. So bring up anything you've seen recently that's interesting, whatever you like.
Yeah, I have seen a lot of definitely WebAssembly seems to be very exciting in this edge area. So other than WebAssembly, there seems to be a lot of on the telecom side, you can say networking side, there's a lot of solutions, but there's not a lot of a community kind of a collaborations. Like maybe it's just individual vendor do their own thing or what. That seems to be the case. But at the same time, there's a lot of innovation on the hardware side as well, on the edge side. So maybe it'll be interesting to just talk about what is out there that just making it like roadblocks for the edge computing. So WebAssembly is popular because it's kind of a disruption in the abstraction layers, right? So what needs to be done in the hardware side or anything in this area for the edge computing to move to the next level?
If I can jump in on that one, you mentioned telco, so I linked the biggest thing in telco and WebAssembly that I know with, which is this group of a consortium of telco companies have gotten together under their version of the CNCF, which they call TM Forum. And they've started to build out, some WebAssembly based projects. So this one in particular features 2 of the 3 entrants that they had this year. It is what they call Open Digital Architecture Components, or ODA. So think like standard telco backplane services that everybody builds and shares. They actually have standardized on those so that the vendors can sort of target a common place. So think like service discovery, charging for phones, metering, billing, stuff like that. And then there's also some shared 5G charging infrastructure, which is, how do you meter minutes across family plans and that kind of stuff. They built this on top of Wasm Cloud, but this is a group of community members in Wasm Cloud that did this. Vance is the gentleman featured on the video. He's actually working on a case study for the CNCF now for CNCF Wasm Cloud. On the hardware side, on other industries adopting WebAssembly, I want to say it's very broad. And the big excitement is the component model, because you get languages and SDKs for free. You know, the language tools create components, and then if you support components, you get that stuff for free. So there's a ton of reason why people are adopting it. And on the private side, you know, we see everybody from big software shops to hardware manufacturing to automotive to power and industry, all adopting or at least experimenting with WebAssembly. We push people to go open and blog about it. You can check out blogs from, say, Colin Breck, who is the head of Tesla Powerwall and software engineering. He blogs about CNCF Wasm Cloud from time to time. He's a really interesting person. He's done some presentations at S3 if you haven't seen it. When you get to the hardware, there's really 3 WebAssemblies that are out there. And it really lines up well to some of our confusion over Edge, you know, that we run into in this group. You have browser-based folks, which you know, is primarily 3 or 4 different groups. You know, you've got the 3 engine cores for V8, Safari, and a Spider Daemon, which is Firefox, and then Node.js. And then you've got all the folks in Linux, which is where CNCF Wasm Cloud sits, and CNCF Wasm Edge. And then you've got the really small sub-Linux folks, think embedded. And the embedded folks primarily use a runtime from Intel that's called, originally out of Intel, called WAMR, WebAssembly Micro Runtime. And that Sony team that built the project and had the booth and all the WebAssembly signage at the CNCF at KubeCon, which is using WAMR. That's an embedded project, so there's no Linux on that. So there'd be no Kubernetes either. And that's super interesting. But what's even more interesting is that they're all in the process of adopting the component model. So even across the 3 different runtimes, you're looking at having a software artifact that's standardized and portable. And that, I think, is, you know, when you look at what really accelerated containers, it was accelerating on one instance. There was the Docker moment. If you followed it, you know, cgroups and namespaces, which is what containers are built on in the Linux kernel, were put in the Linux kernel in like 2007 or something like that. But it wasn't until 2012 that we really coalesced around Docker, and Docker donated their IP. And then shortly thereafter, we had, you know, then standard orchestration patterns evolve around that. And you want that. Everybody wants that, because you want to be able to take your container to ECS or Fargate or Kubernetes, or I don't know if anybody still uses Mesosphere, but I'm sure somebody still does, or any kind of platform. And with WebAssembly, we want the same thing as well. So WebAssembly has been kind of evolving as a standard for the last few years, but getting to the component model is really the Docker moment for WebAssembly. So I expect to see growth to pick up pretty rapidly and continue to accelerate in the space. And I expect to see CNCF continue to be influenced as we see runtimes or platforms throughout the CNCF adopt and embed WebAssembly. Istio and Envoy have WebAssembly embedded. There's lots of little stuff like KubeWarden. There's bigger stuff like CNCF Wasm Cloud, which is about to go incubating, and a few other things. I don't know if that was helpful on what needs to happen on the hardware side, or that approach, or if there's any follow-ups you'd be curious about.
I got a question/comment. So just want to make sure I understood your point. I'm well aware that WebAssembly for Edge has some attractions, being CPU agnostic, being maybe lighter in resource than Docker-like containers, also having more deterministic startup times and runtime execution. But it seems like you're making the point that the most important aspect of it, which wasn't frankly on my list, was this interop where you could write components or services in a multitude of languages, just whatever little niches of your team are good at, and then patch them together at runtime. And that you think that really is the biggest advantage of WebAssembly compared to the other things?
Let's look at a WebAssembly module. If you can give me screen sharing, I'll share. I'll open up
just a minute.
So the WebAssembly standard, you know, really has a couple layers in it. There's the sort of core standard, which defines two artifacts for what is called a WebAssembly module. And what that is a there's a .wasm, think like the executable, and then there's a .wat, which is like the human readable. So this is a repo that my CTO put out for a conference called KubeCon, and there's a version of this up on Cosmonic, but I want to point you at like a neutral one, where we've got some C component here that we're going to compile into WASM. Now, with a regular WebAssembly module, you output, you get, a binary that you can execute, and then a WAT file here that is, like just integers. WebAssembly is the CPU, so you just sort of have, integers in a trench coat here, on the internals. It's easy to read. Now, to make it a component, what we do is you wrap it with this wrapper that says component, and down at the bottom, you also are putting in, a statically typed imports and exports for this module. Think of it like, this module takes in a string and it puts out a vector, something like that. It doesn't really matter. Now, logically, it looks like this. All right, so we have WebAssembly module that has separate memory, table, globals, and this runs on a WebAssembly runtime. Now, when it becomes a component, you suddenly have this static typing here for what this component takes in and what this component puts out. And what's important is that these static types are uplifted across various languages. So when we think about taking these components and putting them together, you could take a component written in C and snap it into a component written in Go. That's really powerful because it lets us sort of stop rebuilding the whole world across languages and runtimes and frameworks when we have this kind of layering here and putting things apart. Now, the components themselves, when we think about composing a component, a WebAssembly module is not going to run unless all of its requirements are satisfied. Now, they can be satisfied by other components or by runtimes themselves. So it gives us a variety of worlds where runtimes can choose to do a big piece of the world or a small piece of the world. Now, some people will say, hey, what if we just did POSIX here? And generally, I think the bulk of WebAssembly thinks that's a really bad idea. And the reason for that is we have a good abstraction for POSIX called a container. And the problem here is that if we had POSIX as our abstraction, think about how we'd have all 530 system calls essentially represented here. All the network stuff, connect, file stuff, like file open, et cetera. Here, time, clocks, all that stuff. There's so many advantages to doing these micro ABIs, application boundary interfaces. One of the key things is that these are now composable. So when you build an application or a WebAssembly module, the only thing that shows up in that module are the imports and exports. So from a security basis, this WebAssembly module here uses some theoretical interface called WASI GPIO. Maybe it's a video game controller and it's got logging, but there's no network connect, right? There's no file open, right? WebAssembly is better than deny by default. It's nothing by default. So there's all these advantages that the WebAssembly component model brings here. And to me, this is what we've spent all year building in WebAssembly is the component model. And then this is, I think, the sort of like, the big deal for what happens. And right now, from a roadmap perspective, we're past now. I'm gonna give you all Spaceballs on you. I'm sorry. The roadmap's a little dated. There's only a handful of things that need to land here around resources and handles. And then we'll be really close to this release, which is WASI.2. And that release is 2 weeks away, that we're going to vote on that standard and have that out. So all this stuff is real. You can build on it now. And this is exciting from that perspective. From a community, this is like what the Bytecode Alliance does. We've got the core WASM standard, which is W3C, the web component model, which builds on top of that. and then a bunch of proposals for these little worlds. Worlds are like, think of them as like collections of system calls, you know, but you can make your own worlds. So the WASI HTTP world is a collection of calls for, you know, HTTP receivers and HTTP responders. A WASI CLI is very close to what you would get in like a command line world, and it's composed of all these sub WASI specifications like file system and so forth. There's a what's neat is in the community, like, you know, outside of all the standards folks, we see a whole ecosystem already blossoming. And what I mean by that is people have already built tooling to make components out of Rust, Python, JavaScript, TinyGo, Big Go's on the way, all the static langs, Zig, C, C++, all that stuff. There's a registry on the way, and then there's a whole world of other WASI interfaces that are being proposed. This whole section right here is very similar to like the whole idea behind WASM Cloud, which was Lego blocks for building cloud applications, and WASM Cloud is now actually standardized on these sort of interfaces here as we're getting them out the door. Is this helpful? Anybody have any questions about this, or trying to like wrap your brain around the component model? I know it can be a little bit.
Yeah, that was really helpful. That you definitely made your point on why this interop is maybe more important than these other benefits of WebAssembly for Edge. I'm just wondering, in terms of these standardized components, what might already be available, because I can see that, you know, there, with the advent of these new hardware devices, there's a lot of new greenfield edge devices that are going to come about, but they're going to want to link up to the legacy things as well as higher level things on the IT stack that are maybe just generic Kubernetes hosted over IP networks. What's there in terms of component model or interfaces to get up onto message buses or to generate cloud events and things like that that run at those higher tiers in the app stack?
That's a great question. The center of that work is a proposal that's called WASI Cloud, and this is you know, the sort of genesis story for this idea from the WASM Cloud perspective. You know, when we were analyzing our software at Capital One, you know, we noticed that most of our source code was the same because we just provided templates by language with all your boxes checked. Two, most of those applications used a very small number of capabilities, right? The standard, you know, like out of the thousands and thousands of microservices, most of them just used HTTP, KV, SQL, S3, which is Blob Store, logging, you know, OTel, and a few others. So those are the things that the WASM Cloud community focused on making sure we had great support for first, were those interfaces. You go from there. Now you can actually define your own interfaces and build out your own things very quickly. This is a really extendable. Let me pull up a cheat sheet here real fast. You program them in a language, or you write them in an IDL that's called WIT, WebAssembly Interface Types. And in theory, there's supposed to be a cheat sheet here. Let me go out to the docs. But WIT is the IDL where you sort of define these, new, you know, these new contracts. And there's a ton of contracts that are being defined behind the scenes at really low levels. You know, we're collaborating with a consortium of folks now on WASI sensors, which would be like low-level stuff like I2C, you know, things in that nature. And Intel has a thing that they call a WASI NN, which we've built, is supported in WASM Cloud already, CNCF WASM Cloud. And this is essentially a interface that brokers machine learning on Edge. So we use this in some of our ML demos to sort of connect to TensorFlow and Onyx models when we're building them out. But this essentially operates on the other side of the WebAssembly boundary. I think what's really fascinating here, let me pull up a different Miro, is it's on this one. It's not there. Is this is the sort of tenancy options that you have when you're building with something like Wasm Cloud. And this would take Wasm Cloud for any WebAssembly distribution or runtime. You essentially have a set of capabilities here when you're building your applications, and you can start using these Lego blocks, like web servers, ML providers. And we sort of need to understand, are these when you're satisfying a WebAssembly component here, when you're satisfying a component and you're building this out, this can be satisfied by the runtime, or by the guest, by other components, by the host runtime, or you have flexibility, and that's by design, because there are times when you may want your WebAssembly module to be satisfied by another component, so it stays inside of the WebAssembly sandbox, right? Each one of these is running in its own separate sandbox. There are other times when you may want it running natively in the host for ultra fast performance. Think like an HTTP server or a SQL server that's going to maintain a bunch of connection pools and reuse sockets, things like that. Or there are times when you may even want to sort of just act as an interface to an existing platform. And this could be, this isn't that different than accessing an external GPIO or sensor provider or something like that, or an ML model. And this is the way WASI-NN works, it enables a sidecar approach, if you will, to accessing external hardware powered ML. There was a presentation at WASM Day where a team actually compiled ML into WebAssembly as a WebAssembly component. And the key difference between the two was, what are your design criteria? Do you want radical portability, in which case you would pull it into the WebAssembly, sandbox, or do you want maybe better performance or more pluggability or modularity, doing it outside the sandbox? Steve, did that answer your question around extending these, or what does the flow look like?
Yeah, that was some interesting background. It sounds like there's stuff in place, but it's still growing. So that looks like a good story to me.
Yeah, it's exciting from a time perspective. It's an exciting time to be in WebAssembly, that's for sure. And the component model is, I think, a great time to jump in. What it gives you is, when you're writing WebAssembly programs, components here, it means that they're portable now. So you can run them on Wasm Cloud. And if you're not happy with Wasm Cloud, or you want to use a different runtime that sort of optimizes for different behavior, you can move that to the different runtime. That's a big deal. It really is the Docker moment for WebAssembly, is the sort of shortcut that I would say from that perspective.
Yeah, it looks like there's probably a great opportunity to add more of these standardized interfaces too. Like I say, to do the legacy interop, because we all know that the world doesn't change in a big bang thing where everything changes at once. And I think the edge devices might be the ones that get out there, maybe even in proof of concepts, but in order to be useful, they're going to have to link up to what you've got now.
Yeah, I think from a programming point of view, the big ones, really become stuff like threads, resources and handles, naming and versioning. This enables a ton of functionality. And when we look at people that talk about using WebAssembly, like the Amazon Prime WebAssembly, their blog post here, they haven't put out much more information beyond this blog post. I've asked them to do a talk. I'm going to ask them again in Europe. This team's based in London. But when you look at the sort of pieces of WebAssembly that they're using here to sort of get to this better performance that they're doing with WebAssembly, they've got some neat use cases in here. They're using threads. They're using a lot of advanced stuff in WebAssembly. They've been real trailblazers to build this, and 37,000 lines of Rust code supporting 8,000 unique devices. That's pretty impressive. when you're looking at their result of improved stability, CPU consumption, smaller memory. And ultimately, I think the biggest impact for them was, and I'm not trying to speak for this team, I'd love to ask them that question, but from reading it was the ability to update faster. Before they moved to WebAssembly, they were only updating their monolith annually because it was risky and a pain in the butt. And they had to build, all the unique versions. But this enabled them to sort of iterate, very quickly in order to get to a solution. What's missing? What's next from WebAssembly when we look at from a standards perspective? And this is going to be renamed to WASI 0.2. And in WASI 0.3, the big thing that will ship will be async. And async is, for the non-developers, a way to, basically wait for work to come back to you. So I can, do something and then say, let me know when you're finished with that so I can pick up my work again. And the async will have a pretty neat set of impacts on WebAssembly. But these various versions here will be compatible with each other as we look at backwards compatibility, and so that's a guarantee that the community is accepting that, if you're building here, you'll be able to move back and forth between them.
You led me to a follow-up question then, talking about these components and versions of them. What's the equivalent here, or has it even materialized yet, of Docker using OCI containers and registries like Docker Hub or your own stand-up registry? Right. Has the WebAssembly community standardized on one thing, or is it still open for future resolution?
That's a great question. So the storage for WebAssembly artifacts is OCI. So that's a big deal because you can put these things in the same place as you put your Docker containers, right? So that works out of the box. And we push these things to GHCR, all the time. Let me pull up my own GitHub. For example, here, if I look at my projects, no package is what I want to look at. This is, my just a GitHub container registry, my GHCR, and these are all WebAssembly components here. Got 1.71 million downloads. That's insane to me. WebAssembly is more popular than I thought it was. That's kind of crazy. But these are super tiny, so there's probably a variety of things that are happening here to make these things, to make this happen. But there's just a lot of things that are there. Now, what's neat about WebAssembly that you'd want to know is all the metadata that's associated with WebAssembly. And the metadata for WebAssembly is stored in an upstream registry called WARG, which is a registry and prototype that lets you sort of start with a WebAssembly module and then pivot to the metadata around what are the imports and exports, what does this component require? Why do you care about that? Because it lets you start to think about these abstractions as, functions. So instead of saying like, hey, I want Redis, you don't import Redis, you import WASI key value. And so then you can ask the registry and say, show me everything that supports WASI KV, Redis, AWS Elasticache, what's the Vault, NATS, Jetstream. There's 4 different options that we just named off the back of our minds that perform the same function, but give you radically different guarantees and functions. Vault is encrypted and private. Redis is, kind of a standard. NATS is distributed and baked into a message queue.
If you don't mind, let me butt in then, because correct me if I'm wrong, but that sounds like a cool idea if what you're saying is by breaking out the metadata, you don't pay for the overhead. You could have shipped the metadata with the runtime, but then the runtime gets fat and you don't actually need that at runtime. So by putting it into a separate area, at development time when you're going to use it, you have access to all this stuff, but you don't pay the tax when you ship it. And I assume, are these like signed and cryptographically authenticated so that the metadata is actually really legitimately associated
Right.
with what you're about to use so that you could use it
Yeah.
for security scan purposes?
Let me answer you. Answer two questions here. So when you have a module in your hand, you can read it and you can see what it imports and what it exports. You know, you can read the WebAssembly module itself, and you can sort of say, hey, this module imports this standard and exports that standard. But what the registry gives you then is a sort of a discovery of components that match those particular interfaces and APIs. It's a neat way. It's a neat little innovation in software. I'm sure it's been done before, but I don't know where to get out there. Your second question was around security. Let me pull up a different mirror for there, because the WebAssembly security module, I think this is very nuanced. So it starts in the core WebAssembly runtime itself, just a virtual CPU. In here, you get lots of the same guarantees that you'd want. You know, data can't be executed as code, but there's no buffer overflow problems. Module can't be modified at runtime. And you get these sandboxes. And when you're running it in production, you're building sandboxes as sandboxes. Now, the component model gives us share nothing linking. So what that means is that, you know, this memory here is separate from this memory here. Now, there is a standard that's called resources that would let these two modules point to some external piece of memory or data, and it has an ownership concept as well to keep you from copying data from outside the WebAssembly boundary. Say I'm right here in Linux to inside the boundary. And an easier way might be to think of it as here. You know, I'm in this firecracker in my Blue operating system, and I have some, you know, blob of data. I may want to use it across multiple WebAssembly sandboxes without copying it into that little tiny virtual machine there. So that concept is supported. That's a big deal for performance there. It also gives us virtual platform layering. So you get digital twins for free with WebAssembly. You know, because you have standardized on these interfaces, it's easy to plug them with, you know, generics or testing or QA or whatever the case is. As we move into that standard called WASI, where we define our interfaces with the language called WIT, you sort of lay out an API, and then you get things like documentation-driven development, capability standards. WASI all runs under the authority of the host. Deny by default, because you only get what you get at runtime. You know, you get nothing by default. Now this is where a runtime can pick up an application runtime. This is a WebAssembly runtime, and now there's WebAssembly application runtimes like CNCF Wasm Cloud. Now, what Wasm Cloud does is you can take these components and you can they are hashed, but what we add is signing when you upload a module into Wasm Cloud. We sign it for you, ensure that it's tamper-proof. You can sign things multiple times. So we think of this as like the sort of like enterprise features for WebAssembly. You'd want to say, hey, only launch WebAssembly components that have been signed by, you know, corporate security or something like that. You can verify issuers. You get additional values around contract-driven development in the actor model. And then, you know, we ensure that all communications are over TLS. That you can even choose to sign invocations between hosts, so that, you know, like when actor component A calls component B, was that a signed request or not? Because we enable transit. All of these hosts essentially become cattle. But I think the biggest security value prop is write less code, manage less code, right? We stop baking all those common capabilities into every language. I know I'm on my WebAssembly sandbox here, Steve. I hope this is helpful, you know, to sort of like answer your questions.
Yeah, I think you did. I fully agree with that idea of your wrap up of write less code being the biggest aspect.
Yeah. Yeah, absolutely. Okay, any other questions about WebAssembly or the WebAssembly component model or dependency?
So right now, I guess the biggest I guess not phenomena, is more of a, I guess, the open source community and the telecom providers. Because the telecom providers have been building their open source stack using like OpenStack virtual machine first. Then comes Kubernetes. But it looks like after a lot of solutions has been built using both OpenStack and then later Kubernetes, there has not been much open like collaboration after that. There are, but it's just very scattered. There's not like uniformly interest seems to be like in a lot of a more close collaboration with the telecom providers. Definitely, I think one thing that Liam, you have done, I think, really critical to the WASM community is really you're the proponent to do a lot of collaboration in the WASM community, have a standard, right? Before actually competing with each other.
We were, yeah.
What do you think the problem, the symptom of like telecom provider not participating? Is the WebAssembly innovation going to change that in some way? What kind of problem is going to solve to make that happen?
First, let me say that the real people that deserve credit for the better collaboration in WebAssembly, I think, would be the Bytecode Alliance folks. And I would really point to this group of folks right here as the leaders. I work really closely with the Bytecode Alliance. Bailey is the CTO at Cosmonic. But these are the folks that are really driving this. I think I'm a really good voice and proponent. And look, I'm organizing events and developer summits, and I do a lot in that ecosystem, but I really want to make sure that people know where to look for who's really the visionaries here. There's these folks, and then some of the there's two folks that actually aren't on here, that Luke Wagner, who is one of the early creators. Like if you go back to the original ASM.js days, he was one of the engineers at SpiderMonkey that really kind of saw this and got it quick and was optimizing SpiderMonkey to make ASM.js fast so we could all play Doom in the browser. And Lynn is also not on here as well. And she's still at Fastly and is maybe taking a step back from the community, but her code tunes were the ones that originally all inspired us about these ideas to get out there. But let's talk to your second question, which was around collaboration. And I apologize for using a Cosmonic image here, but I think it just helps me to tell the story. From my conversations with telco in particular, much of the world still lives, in the pizza box days, and a lot of them are still trying to get to the, to the Kubernetes days, where they've got a little more portability and containerized things. But the reality is that the more wide you need to go with Kubernetes, the more we talked a little bit at the opening of this call about the weaknesses of Kubernetes. One of the biggest weaknesses is everything's warm with containers, right? Containers have a high cold start time. So the more broad I get, if I need to deploy to 20 or 30 regions to be close to my users, or in telco world, you'd say at your POPs, I suddenly am now hot in all those places, even if I'm not used. WebAssembly is so small, these little components, it has a very low cold start time. So you can go from 0 to 1 in typically 50 microseconds. Whereas network connections are still measured in milliseconds. Let me give you 3 orders of magnitude here. A network connection coming over to a WebAssembly HTTP server would be, 30 milliseconds would be really fast for video gaming. To start this from scratch would be, 50 microseconds. For these two things to communicate to each other or across the WebAssembly host guest boundary here is measured in nanoseconds. So you're able now to exploit, the dramatic performance in local and trade that off against network time. And in some cases, depending on how your application is designed and what it needs, start per invocation or scale per invocation. Now, there are what I like to, and what we thought about this with Wasm Cloud. With Wasm Cloud, we were really thinking like, corporate microservices, like if you're at a big company, you got 5,000 microservices, 3,890 of them look like this. I've got HTTP, SQL, KV. These providers would obviously need to stay hot. And that's a model that we've accounted for in Wasm Cloud, where these providers, including ones you build yourselves, can stay warm, can stay connected, and then they can even be shared by these WebAssembly modules. So we were trying to think through that. How do we exploit that difference between high cold start times, networks, but still letting you build really performance stateful applications? Some of these telco users have brought us some really interesting requirements for like our HTTP server, for example, features that they'd want us to put in. And we're working through those motions with them now. And, I work for a company called Cosmonic. We're open source first, and we plan to put those features into CNCF Wasm Cloud. I think, to come back a little bit more to your question, I think the more we collaborate, the better things are. And it's exciting to see the telco group here did just announce phase 2 of this catalyst. There's even a bunch of new telcos that are joining, is what I've heard. But this is Vodafone, Orange, NBN, a bunch of other folks. And they are now going to finish building out all of the telco services on CNCF Wasm Cloud. So that's a pretty big deal for that particular issue that hopefully will help them accelerate their journey faster.
So in other words, even if telco continue to, because it's hard to replace the pizza box, they will benefit a lot, because just the way the WASM overall is an innovation to a lot of benefits. So even with pizza box, they will benefit a lot from the open source community using WebAssembly.
Yeah, we're working on a case study with them now. I mentioned that earlier, where they're going to tell the story. We're pushing one of the other telcos that's actually a bit further along to do their own case study, or to get them on stage for EU, for KubeCon EU. We're hopefully going to get them to get a couple submissions in, but they've actually been able to jump faster by going right to a hybrid model, where they're running Kubernetes in some of their main data centers, and then out on the edges, they're just running Wasm Cloud, because it's cheaper, it's faster. They just need speed and performance. They don't necessarily need, the full footprint for what they're doing in their main data centers. So it's pretty neat when we're looking at, how the world is coming together. And I think that it will be continued to be centered around this build out to the edges is the next big thing. The last decade was the great lift and shift into the clouds, and the next decade is, well, how do we make this stuff run everywhere all the time?
So in that case, do you think for the telcos that's still on the pizza box, do you think they need to even, does the container orchestration still play a role?
Yeah, I do. Look, I made an analogy with them about, how Asia and, places in China were able to skip wireline and go right to wireless, as an analogy. Like they never stopped in the middle, they never went cloud native, so they can just go right to WebAssembly. But the reality is that there's a lot of great software that's very tightly coupled with Linux, and easy to deploy, manage, and scale through stuff like Helm. So I think that they will continue to have pockets and dedicated investments in resources in today's world. But I think increasingly, to your point, some of the new edge stuff just emerges on Wasm Cloud, whether it's on set-top boxes or devices. I mean, Wasm Cloud runs right on Android, and there's no reason why it wouldn't run on iOS either.
I think it'll be interesting discussion to go over in this group where virtual machine even still makes sense, where containers still make sense, or maybe everything should be WASM one day.
No, I think we have so much software that's tightly coupled to Linux and to the POSIX ABI, and it's highly optimized to do what it does there. So think like MySQL, or like network monitoring tools. They all these crazy tricks for copying stuff off network cards and doing shared ring buffers with the Linux kernel. All that stuff's going to stay in Linux for the foreseeable future because it's just so much work to build it. But just as containers didn't replace virtual machines, and virtual machines didn't replace data centers, there's a world where we have more options, and it's just a better world for developers. You choose the right tool for the right time.
Yeah, it will be stupid to know like where is that maybe hard line where it's impossible to almost to because for example there are areas I think virtual machines still have an advantage over containers, although it's getting smaller and smaller. But it'd be nice to know that where the line is eventually. This way, yeah, people can prepare for the future.
Yeah, well, it's an exciting time to be a part of it, and the wonderful thing is we're all out here building it together. I've got to go. I'm hosting my next meeting at 1 o'clock. It's the WASM Cloud Wednesday. You're more than welcome to join. It's on the CNCF calendar, where we do the WASM Cloud community meeting every Wednesday. I'm special guest host this week. Our normal host is out, so I have to go. But it was awesome as always to have a chance to touch base with everybody. A couple people came by the Cosmonic booth and said hello. I really appreciate that. I'm sorry I didn't have more time. I was just on booth duty the whole time, and when I wasn't doing that, I was we hosted the CTO summit and hosted and then I was chair of CNCF WASM Day. So it's always busy, but my favorite part of KubeCon is a chance to have all my IRC friends and meet you guys in IRL. So I'll see you guys later. Bye.
Okay. Thanks, everybody. It's top of the hour, so we'll end the meeting. See you in a couple weeks. Bye.
Bye.
Bye.